Hi everyone, let's now look at the work done under a constant pressure process. So we're going to just look at a simple example of a cylinder with a piston and a piston rod over here. Okay, so the gas is inside the cylinder and it is doing work and it's pushing the piston up from initial volume 1 to a final volume 2 under a constant pressure process. So how do you derive the work done by the gas? So work done, as you know, is a force multiplied by distance, right? So this force is actually the caused by the pressure of the gas onto the surface of the piston cross-sectional area. Okay, so this force, right, is by pressure. Force equals to pressure times area. So the pressure multiplied by the cross-sectional area of the piston multiplied by distance. What distance is it actually? It is actually this distance. Okay, because the gas manages to push the piston over a distance that is this height over here. And in fact, area times distance is some kind of a volume. Okay, this volume is this difference in volume. Right? The difference in volume 2 and volume 1 will be this effective volume that has been covered by pushing the piston. So it can actually be written as PV2 minus V1. Okay, so let's say we put them in numbers. Let's say V1 is 1 meter cube, V2 is 2 meter cube. Okay, so the actual work done, right, by this gas at 200 kilopascal is 200,000 multiplied by 2 minus 1. So this will give you 200,000, because since they are all in SI units, the answer will be SI unit of joules, or 200 kilojoules of work is being done by the gas. Okay, because the gas is actually pushing the cylinder up, the piston up. Okay, so if you plot it in a PV curve, okay, we will always want to plot them in the PV curve, a PV graph. It will look like this, because constant pressure, it will have the same value pressure here, 200 kilopascal, and it will go from 1 meter cube to 2 meter cube. Okay, state 1 to state 2. So this is where it's going. Okay, and you can see that actually V1, this is V1, this is V2, right? So V1 minus V2 is actually this length over here, and P is actually this height over here, which effectively your work done, right, is actually the area under the constant pressure line here, this process. Okay, area under the process. Okay, you can see that this is the process and the work done is the area under the PV curve. Okay, in strict mathematical sense, it would be an integration from value 1 to value 2 with respect to volume. Okay, integration of the pressure. Okay, so pressure you can take out, and it is just integration dV, which actually give you V2 minus V1. Okay, so this is in mathematical terms how it is